All right, let's get ready to dive into a world that you might think is all like sparks and molten metal. But trust me, there's so much more to welding than meets the eye. We're talking history, innovation, and even artistry. So get ready. Today's deep dive is all about uncovering those hidden layers of welding. You want to understand the basics and see how it's used across all these different industries. So we've pulled together some really cool sources, including Introduction to Welding 101 to get started.
You know what's fascinating to me about welding? It's really how it has evolved from like simple techniques that have been used literally for centuries to these incredibly sophisticated processes that are like shaping our modern world. It's really a story of human ingenuity and a testament to our desire to build, create, and connect things.
Okay, so let's just start with the basics here. What exactly is welding? I mean, I know it involves like joining things together, but what is the science behind it?
At its core, welding is a process that joins materials, and we're usually talking about metals or thermoplastics, by causing coalescence.
Coalescence.
Yeah. Think of it like this. Imagine two pieces of clay. You soften them with a little bit of water, press them together, and they become one. Welding does something similar, but with heat and sometimes pressure to fuse those materials at an atomic level.
So it's not just sticking two pieces together, it's actually making them one solid piece at a microscopic level.
Exactly.
Yeah.
And to make that bond even stronger, a filler material is often added. It's like adding extra clay to our example to reinforce that connection.
That makes a lot of sense. And speaking of heat, I noticed that our sources mention a bunch of ways to generate that heat for welding, like gas flames, electric arcs, lasers, even things like electron beams, friction, and ultrasound.
It's amazing how diverse the energy sources are.
Mhm.
Each method has its pros and cons depending on the materials, the precision needed, and even the environment that you're working in. It's like choosing the right tool from a toolbox. But instead of hammers and screwdrivers, we're talking about harnessing the power of focused energy.
So it's not just a one-size-fits-all process. There's a whole spectrum of techniques. Now, Introduction to Welding 101 really hammered home the importance of safety, which makes a ton of sense considering all that heat and energy involved.
Absolutely. Safety is really paramount in welding. We're dealing with extreme temperatures, molten metal, and potentially harmful fumes and radiation. That's why personal protective equipment, or PPE, is non-negotiable. Those welding helmets and gloves you see aren't just for show, they're a welder's first line of defense.
They do look pretty serious in the pictures, so it's not just about knowing how to weld, it's also about understanding and respecting the safety protocols.
Precisely. A responsible welder is a safe welder. It's crucial to inspect your equipment before each use, understand the properties of the materials you're working with, and maintain a clean and organized work area. A cluttered workspace can increase the risk of accidents and make it harder to respond effectively in case of an emergency.
It sounds like good habits and attention to detail are super crucial in welding, maybe even more so than in other fields.
Absolutely. A safe welding environment is a productive one. Now let's move on to the different types of welding processes. Introduction to Welding 101 highlights 4 common ones that I think we should talk about. I know it might seem like jumping into the deep end, but I think understanding these types will give you a good foundation for exploring the world of welding.
All right, I'm ready to dive in. What are these core welding processes?
We have shielded metal arc welding, or SMAW, gas metal arc welding, GMAW, gas tungsten arc welding, GTAW, and flux cord arc welding, FCAW. Now, I know that's a lot of acronyms, but don't worry, we'll break each one down.
Okay, that's helpful. But before we do, could you give me an example of where I might encounter these different types of welding in the real world, just to put these acronyms in the context?
Of course. Think about it this way. If you're driving over a bridge, chances are SMAW is used in its construction because it's so versatile and portable. Then your car itself was likely assembled using GMAW, as it's known for its speed and efficiency in manufacturing. If you see a beautifully crafted metal sculpture, that intricate work was probably done with GTAW, known for its precision and artistic capabilities. And finally, those pipelines transporting oil and gas across vast distances are often welded using FCAW because of its durability and ability to handle tough outdoor conditions.
Wow, it's incredible how each welding type has its own specialty and plays a crucial role in different aspects of our lives. I never realized how prevalent welding is.
It really is. It's one of those things we often take for granted, but without it, our modern world wouldn't function as we know it.
That's a great point. So now that we've got a taste of the different welding processes and their real-world applications, I'm really curious to learn more about how each one works.
Excellent. Then let's start with SMAW, often considered the workhorse of the welding world. It's a great place to begin understanding the fundamentals of welding with an arc and a consumable electrode.
All right, let's fire up those welding torches, metaphorically speaking, of course, and delve into the world of SMAW.
Welcome back to our deep dive into welding. I'm excited to keep unpacking these different welding processes with you. Now, where were we? Ah, yes, shielded metal arc welding, or SMAW, the trusty workhorse.
Exactly. You mentioned it's often used in bridge construction. What makes it so versatile for those kinds of large-scale projects?
Well, for starters, SMAW is relatively simple to set up and use. It doesn't require a lot of fancy equipment, and it can be used in a variety of environments, even outdoors and in challenging weather conditions.
Okay, yeah, that makes sense for something like bridge construction where you don't always have a perfectly controlled environment.
Exactly. SMAW relies on a consumable electrode coated in flux. As the electrode melts, it creates the weld pool, and the flux burns off, creating a shielding gas that protects the weld from atmospheric contamination.
So the flux is kind of like a built-in protective layer.
Exactly. It prevents impurities from weakening the weld. Now let's contrast that with gas metal arc welding, or GMAW, also known as MIG welding.
You mentioned GMAW is used in car manufacturing. What makes it a good choice for that kind of assembly line work?
Speed and efficiency. GMAW uses a continuous solid wire electrode fed through a welding gun along with a shielding gas, usually argon or a mix of argon and carbon dioxide. Because the wire is fed continuously, you don't have to stop and change electrodes as often as you do with FCAW. It's a much faster process.
So it's all about keeping that production line moving. That makes a lot of sense for mass production. But you also said that GMAW creates cleaner welds.
That's right. The continuous wire feed and the shielding gas create a smoother, more aesthetically pleasing weld with less spatter, those little bits of molten metal that can fly around during welding. This is why GMAW is also a popular choice for projects where a clean, finished appearance is important.
Okay, so if somehow DA is the rugged workhorse and GMAW is the speedy manufacturer, where does that leave gas tungsten arc welding, or GTAW, also known as TIG welding?
Ah, GTAW, the precision artist of the welding world. This one uses a non-consumable tungsten electrode to create the arc, and a separate filler rod is often used to add material to the weld.
I remember you mentioned seeing those beautiful metal sculptures, and I immediately thought of those mesmerizing TIG welding videos online with those glowing arcs and perfectly smooth welds.
That's a great connection. GTAW is all about precision and control. It allows the welder to fine-tune the heat input and create incredibly intricate and aesthetically pleasing welds, which is why it's often the preferred choice for aerospace applications, artistic metalwork, and situations where weld quality and appearance are absolutely critical.
It sounds like GTAW requires a really high level of skill and patience.
You could say that. It definitely takes practice and a steady hand to master TIG welding, but the results can be truly stunning. Finally, we have flux cord arc welding, or FCAW.
This one is a bit of a mystery to me. How is it different from the other processes we've talked about?
Well, FCAW is similar to GMAW in that it also uses a continuous wire electrode fed through a gun. However, in FCAW, the wire is hollow and filled with flux, similar to what we saw with SMAW.
Well, it's like a hybrid of the two, combining the speed of GMAW with the self-shielding properties of SMAW.
You got it. That's a great way to think about it. This makes FCAW quite versatile and adaptable. It's a great choice for outdoor welding, especially in windy conditions, because the shielding gas comes from within the wire itself, so it's not as easily blown away. You'll find FCAW being used in construction, shipbuilding, and pipeline welding, often in situations where portability and the ability to weld in less than ideal conditions are important.
Okay, so we've got SMAW, the all-rounder, GMAW for speed, GTAW for precision, and FCAW for toughness and adaptability. It's incredible how each welding process has its own personality and strengths, making it suitable for such a diverse range of applications.
It really is. And what's even more remarkable is that we've only scratched the surface of the welding world. There are countless other welding processes out there, each with its own unique set of characteristics and applications, from laser beam welding to resistance welding and beyond.
Wow, it sounds like a whole universe of possibilities. It seems like every time we uncover one layer of welding, there's another even more fascinating layer underneath.
That's the beauty of exploration. But before we get too carried away with all the different types of welding, I think it's important to step back and consider the bigger picture. We've talked about how welding is used in bridges, cars, pipelines, and even art, but it's so much more than just joining pieces of metal. It's about connecting people, ideas, and industries.
That's a really interesting perspective. It's easy to get caught up in the technical details and forget about the human element behind it all.
Absolutely. Think about all the people involved in a major construction project, for example. You have architects, engineers, welders, and countless other skilled tradespeople all working together to create something that benefits society. Welding is the thread that binds all those efforts together.
It's like a silent hero working behind the scenes to make our modern world possible. I never thought about it that way before.
And it's not just about the present, it's about the future as well. Welding plays a crucial role in advancing technologies and pushing the boundaries of what's possible.
That makes sense. Welding must be involved in everything from building spacecraft to developing new forms of renewable energy.
Precisely. And as technology continues to evolve, we can only imagine the exciting innovations that welding will help to bring about.
It's mind-blowing to think about the possibilities. But before we get too lost in the future, I'm curious to hear more about the history of welding. Did people always weld the way they do now?
Not at all. The history of welding is as fascinating as its present and future. In fact, some forms of welding have been around for millennia.
Really? What kind of welding did ancient civilizations use?
Believe it or not, forge welding, which involves heating metals and hammering them together, dates back to the Bronze Age. It's one of the oldest known joining techniques, and it was used to create weapons, tools, and even jewelry.
Wow, that's incredible. To think that people were manipulating metal at such a fundamental level thousands of years ago is truly humbling.
It really is. But of course, welding has come a long way since then. Throughout history, there have been numerous breakthroughs and innovations that have transformed welding from a rudimentary craft to a highly sophisticated science.
I'm eager to learn more about those breakthroughs. What were some of the key moments in the evolution of welding?
Well, one of the most significant milestones was the invention of arc welding in the late 19th century. This technology, which uses an electric arc to create the heat needed for welding, revolutionized the industry and paved the way for many of the modern welding processes we use today.
So arc welding was the game changer. It sounds like it opened up a whole new world of possibilities for joining metals.
Absolutely. It enabled the creation of stronger, more efficient, and more complex structures than ever before. It was a pivotal moment in history, shaping industries like shipbuilding, construction, and manufacturing in profound ways.
It's amazing to think about how one invention can have such a ripple effect across so many aspects of society.
It really highlights the interconnectedness of technological advancement. And speaking of interconnectedness, let's talk about another key moment in the history of welding: the development of resistance welding in the early 20th century. This process, which uses electrical resistance to generate heat and join metals, was a critical enabler of mass production.
Ah, so that's how things like car bodies and appliances started being made so efficiently. I always wondered how they managed to weld those large sheets of metal together so quickly and consistently.
Exactly. Resistance welding was a game changer for mass production. It allowed for the rapid and automated joining of sheet metal, leading to a surge in the production of everything from automobiles to household appliances.
It's fascinating to see how welding went from ancient forge welding to these more modern techniques that revolutionized entire industries. It makes you wonder what the future holds for this ever-evolving field.
That's a great question. And as much as I love delving into the past, I'm equally fascinated by what lies ahead. Perhaps it's time we turn our attention to the future of welding and explore the cutting-edge technologies that are pushing the boundaries of what's possible.
Lead the way. I'm ready to see what the future of welding has in store.
Okay, so we're back for the final part of our welding deep dive. We've covered a lot of ground, from ancient forge welding to modern techniques like GMAW and TIG welding and all that. I'm ready to jump into the future now. What kind of innovations are shaping the world of welding these days?
Well, one of the most exciting areas to me is automation and robotics. Imagine robots that are capable of performing these really complex welds with incredible speed and precision. It's pretty crazy. That sounds really impressive, but I have to admit the idea of robots taking over welding tasks is a little unsettling. What happens to all the human welders? Do their skills just become obsolete?
No, not at all. Think of it more as a collaboration rather than just like a replacement. Robots can handle those like repetitive or hazardous tasks, but they still need human expertise to program them, operate them, and maintain them. Skilled welders are going to be essential for ensuring quality control, troubleshooting issues, and adapting to new technologies.
So it's more about evolving with the technology rather than being replaced by it.
Exactly. The future of welding isn't about humans versus robots. It's about humans and robots working together to achieve greater efficiency, precision, and safety in the field.
Okay, that's reassuring. What other futuristic welding advancements should we be keeping an eye on?
Well, material science is another area that's really pushing the boundaries of welding. We're seeing the development of all these new alloys and composite materials that require specialized welding techniques.
Can you give me an example?
Yeah. For example, think about the lightweight yet incredibly strong materials used in aerospace and electric vehicles. They demand cutting-edge welding processes to ensure structural integrity.
So welding is evolving alongside the materials themselves, adapting to meet new challenges and possibilities.
Precisely. And we're even seeing research into self-healing welds, which sounds like something straight out of science fiction. Imagine a weld that can repair itself if it gets damaged, increasing safety and longevity in critical structures.
No, that would be a game changer. It seems like the future of welding is full of potential with endless possibilities for innovation and advancement.
Absolutely.
Yeah.
And here's something else to consider as we kind of move towards a more sustainable future. Welding will play a crucial role in developing and manufacturing renewable energy technologies like wind turbines and solar panels.
That's a great point. It's encouraging to think that welding will be at the forefront of building a more sustainable world.
It really highlights how interconnected welding is to our lives and to the future of our planet. It's not just about joining metal, it's about joining forces to solve global challenges and create a better future for everyone.
Well said. It seems like every time we peel back a layer of welding, we uncover a deeper connection to humanity, innovation, and progress.
And that, I believe, is the essence of a true deep dive. It's about going beyond the surface, exploring the interconnectedness of things, and emerging with a new perspective and a renewed sense of wonder.
Well, I can definitely say that this deep dive has totally opened my eyes to the world of welding. I went from knowing next to nothing about it to being amazed by its history, its diversity, and its impact on our lives. So thank you for that.
It's been a pleasure sharing this journey with you. I hope you've come away with a newfound appreciation for this often overlooked but vitally important field.
I absolutely have. I'll never look at a bridge, a car, or even a skyscraper the same way again. There's a whole world of skill and artistry hidden beneath those seemingly simple welds. It's really amazing.
And remember, this is just the beginning of your welding exploration. There's a wealth of information out there, from books and documentaries to online communities, and even welding courses if you want to get hands-on.
You've definitely sparked my curiosity. I might even try my hand at some basic welding someday. Who knows, maybe I'll be building those self-healing structures in the future.
You never know. But for now, let's just savor the knowledge we've gained and keep that spark of curiosity burning.
And with that, we've reached the end of our welding deep dive. Thank you for joining us on this journey of discovery. Until next time, keep exploring, keep learning, and keep welding those connections.